So I wanted to remind you of the limit laws because we are going to be using calculating limits. So it might be helpful for us to remember the limit laws. So the first one says if you take the limit of a sum, I can break it up as the limit of each piece plus the limit of bn. You would have the same formula for subtraction. I'm not going to write it, but you would also have the same formula. So maybe I'll write plus or minus here. You can pull constants out of limits. So if I have the limit of c a of n, you can factor the c out if it's a constant. If you're computing the limit of a product, you can split it up as the limit of each term and multiply them. And then the last one that I'm going to mention is with division. An over bn, you can split it up as two limits provided only when you know that this limit of the denominator is not 0. Okay, so those were all hopefully limit laws you saw way back in Calculus 1, and they're things that might be helpful to you when you're computing limits here. The other thing that you also had when you did limits before was the squeeze theorem for limits. We also have a squeeze theorem here as well. Okay. So let me write down what the squeeze theorem in this case is. It says if you can put your sequence between two other ones, hence the squeeze part, if you can squeeze b sub n in between an a sub n and c sub n for n bigger than some fixed number, capital N is what I'm going to use, and the limit of the two ones it's squeezed between, a sub n and c sub n, are the same, then the limit of b sub n is also L. When I see a squeeze theorem, I like to think of a certain picture in my head, so I kind of want to give that to you so you can see it as well. So you have three sequences going on, so maybe I'll try to use three colors. So let's say a sub n is going to be this black sequence. Remember, sequences are just points. Those are really light dots there. And it's going to have some limit L, okay? And then C sub n, because of the inequality, it's forced to be larger than this sequence A sub n, so it's going to be maybe down here, or sorry, up here, and it also has limit L. So it's converging to L. So what's happening is this sequence B sub n, it's trapped in between these two sequences. So no matter what it looks like, it's going to be trapped between these two colors, this black and this blue, and it's going to be forced to go along for the ride. It's going to be forced to have the same limit just because it's trapped between two other sequences that have the same limit. Okay? So that's kind of what I think of in my head, is that the middle one is trapped in between these two other ones. Questions on that? Okay, so the last theorem I want to give you that we're going to use to calculate limits of these sequences is the following one. Which says if the absolute value of a sub n, the limit in that case is 0, then the limit of your sequence is also 0. Okay, so this kind of theorem helps you a lot when you have, we saw that example with the alternating sign, positive, minus, positive, minus. This helps a lot in that case, this theorem. So if you're, what I'm saying is, if your sequence is alternating, use it for the alternating sequences. And it should help you calculate a limit then.